So just like with all of our sets of notes, we need to fill out this top section before we get started. So remember our unit is 611 ratios. You also need to include your name and today's date. And then our essential question is which lesson you're on. So today we're on lesson number 5, graphing, ratio, relationships. And I know this is actually part 1. And once you have that filled out, we can go ahead and get started with the notes. To get started today, we actually first need to define the different parts of a graph. And there are quite a few. The most important, or I guess they're all important, are our axes. So going across horizontally is the x-axis. Going up and down vertically is our y-axis. And then these two axes cross or intersect at one of the most important points on our graph. It's the point 0, 0, which we call the origin. The next thing that we're going to define is our dependent and independent variable. And we're going to talk a lot more about this in science class, but for now we need to know that on our x-axis, so going across, is our independent variable. This is the thing that we are controlling and not changing. Then on the y-axis is going to be the dependent variable. These are your results of what's going on with that independent. Also, when we look up here, we see that we have all of these numbers across the bottom and up the side here, and they're ordered evenly. We call that our scale. And here we have another scale. Notice they don't need to be the same on your different axes, but they need to be counted evenly. Here we counted by ones, and on the y-axis we counted by tens. So we need to keep our scale in mind. And those are the different parts that we need to recall. And so when we make our own graphs, we have 4 steps to graphing. And so the first thing we need to figure out is to determine the independent variable. Because if we know that, we know which variable is going to go on the x-axis. And we can figure that out by asking ourselves the question, which quantity determines the other quantity? So what's impacting that other thing? After we know our independent variable, so we can label our axes, that's our next step. We're going to have to label the axes of our graph. Now that we know the x and the other item would be the y. Once we have that labeled, we are going to pick and then label our scale for our 2 different axes. Remember, they don't need to have the same scale. So we can count by 2s on the x and 10s on the y, and that's completely fine. But we just have to make sure we're counting evenly. And then lastly, to finish up our graph, we are going to have to plot the points from your table. And then once you have your points down, we are going to connect them or connect the points using a straight line. So all of you should have a ruler to make your lines nice and straight. And so now we're going to go ahead and practice all of this. And we are going to graph the following table. The first thing we want to do is look at our table. So looking here, I see we have time and we have distance. So if I thought about a situation, it's how many feet could I run in so many seconds? So in so many seconds, how many feet do I run? And so the first thing we have to do is find our independent variable. I know time is my independent variable, or the x, which makes distance my dependent variable, or the y. If I run 2 seconds, I go 11 feet. The amount of time that I'm running is impacting how far I go. The more time I run, the more feet I make distance-wise. So now that we have step 1 done, we can go ahead and look at step 2. Step 2 says to label the axes. So remember, x goes across the bottom and y is up the side. So my x, or my independent, is time. So I have time in seconds. And then up the side I have distance in feet. So I labeled my x-axis and my y-axis. Then the third step is to pick and label a scale. So we're going to look at our numbers. For my time, I have the numbers 0 through 10. So first I want to see if we have 0 in the corner, could I count by ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 lines, and I only have to get up to 10, so I can go ahead and count by ones. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Notice when I number, I'm numbering on the line. I am not numbering in the empty box space. And I want to take up as much of this graph space as possible. So then I need to look at how I should number my y-axis for feet. I see I have the numbers 3 through 43. So if I have to get up to 43, I can try to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, that only gets me to 11, and I have to get to 43. So that's not going to work. So if I know I have 11 lines, and I have to get up to the number 43, what could I count by? Could I count by 2s? No, that would only be 22. Could I count by 3s? Not quite. But I could count by 4s. So I could say 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. Notice I didn't just write down the numbers 3, 7, 11, 15, 19. That would not be even. I need to make sure that it counts nice and even while I'm going up the side. I counted by 4s evenly. Now we're finally made it to step 4, which is to plot our points. So if we look at the first point, it is 0, 3. 0 is time, 3 is feet. So we are going to run, then jump. So I always run left or right, and I jump up and down. We run the first number, jump the second number. So from 0, I run 0, but I jump 3. I don't see a 3. Now, I know if I have to go up 3, that's less than 4. So I need to estimate where 3 is going to be. It's going to be about here. My second point is 1, 7. Run 1, jump 7. So from the start, or from the origin, I run 1, jump 7. Run 2, jump 11. Run 3, jump 15. Run 4, jump 19. Run 5, jump 23. And finally, run 10, so I run all the way over to 10 here, and jump all the way up to 43. And if I do it right, I should connect my dots using a ruler, hopefully, into a nice straight line. And then we like to put arrows on the end of my line to show it goes on forever and ever. And there we have our graph.